back. Today we are going to solve the DE by testing for exactness first. So our first example is x plus sine y dx plus our x, as you can see it here. So we know that whenever we want to test for the exactness of a differential equation or a DE, we know that the partial derivative of m with respect to that of y is the same as the partial derivative of n with respect to that of x. So thereafter, we are now interested in finding a function which is a f, which is a function of x and y, is a function of x and y, and is given by the partial of f with respect to that of x should be the same as the partial of f. So the function f(x) and y should be given by the partial of f with respect to that of x for our function mx of y, and this one should be the same as the partial of f with respect to y of our equation nxy. So somebody will be asking him or herself that where do we now get our m and n? So here the function with x, dx is our m, and that one with dy is our n. So I'll name them m and this is n. So we know that now we want to find the partial of m with respect to y, and is given as the partial of m with respect to y of x sine y, and at this particular point now we know that x is a constant. So what we are going to do, we are now just going to differentiate sine y, and the derivative of sine y is cos y. Then the partial now of n with respect to x will be given as the partial of m with respect to x of our equation x cos y minus 2y. So at this particular point we know that y is a constant and the derivative of x is 1. So this is just the same as 1 times cos y, which is cos y, minus 2y, and our y is a constant, so that is the same as 0. So you will realize that if I name this my equation 1 and this one my equation 2, they are the same, meaning that our equation is exact. So what do we do next? So our next step now, we are going to find the partial of f with respect to x, which is a function of mx and y, is a function of mx and y. So the partial of f with respect to x is given by the the function of x and y, which is x plus sine y. So by cross multiplying, we get the partial of f being the same as x plus sin y, and this time round we are finding we are integrating with respect to x. So this is the same as the partial of f with integrating the partial of f, we get f should be given by integrating x is a half x squared plus, because this one is a constant, we are not going to integrate it, but we know that there is a function x sine y plus some constant, and that constant is is a function of y, because we know that at that particular point y is constant. So I'll name it h of y. Then alternatively, we are going also to find the partial of f with respect to y of our function nx of y, So this is the same as finding the partial of f with respect to that of y of our function x of y, which is x cos y minus 2y. So by cross multiplying, we get the partial of f being the same as x cos y minus 2y. I integrate so that I get f to be the same as, because now x is constant, so I'm not integrating x. X is now, I'll treat it as a constant, so it will be x, and the integral of cos y is just sine y minus, when I integrate this one, I get a y squared plus some constant I'll name as g, which is a function of x, and these ones they should give us constant. This one, they gives us the constant. So by equating, I can equate this my first f to be maybe equation 3 and the other one to be 4. So I'll just say that my equation 4 to be equals to equation 3, such that when I equate a half x squared plus x sine y plus h of y should be the same as x sin y minus, sorry, I'll add here a, but it's just fine. So minus y squared plus some g of x. So by this one, I'll find my function h of y to be, my function h of y will be, because this one cancels out with this, so my function h of y will take negative y squared, and my function g of x will take, because g is here and it will take a half x squared. So I can choose either of the f's, and then if I choose my f now to be a half x squared plus x sine y plus h of y, and my h of y is minus y squared, so minus y squared should give us some constants. I'll name it C1. So thank you and keep watching.